G'day lads, watch this video to learn how to build an Excel model that predicts MLB baseball games with live and updating stats so you don't have to touch a thing. If you want downloadable access to this file, check out the Excel Lads Patreon link in the description below, where you'll receive lifetime access to all Excel Lads files along with the unique ability to directly access myself to help you with any Excel questions. Let's get into the video lads. The first step, lads, is to set up these 5 columns of data. So going from left to right is the list of MLB teams, their runs scored per game, runs conceded per game, runs scored per innings, and then runs against or runs conceded per innings. What I've done for this model is import these stats directly from the Baseball Reference website, and I've done that using a Power Query. The link to these stats will be in the video's description for you lads, and will obviously also be in the downloadable file over on Patreon, so we can see here the rest of the stats I've imported. And to refresh these stats, I can go into the data tab up here and then press refresh all on this icon over here. This will update the data and allow me to predict matches with live and updating stats to ensure maximum accuracy is achieved. Going back into our data worksheet, I'm going to find the average of all these columns using the average function. And all you have to do is equals average and then B2 to B31. Close the bracket and then drag this across to find the average of all 4 columns. Great, so our figure of 4.57 implies that an average of 4.57 runs per game is scored throughout the league. However, you'll notice that only 0.50 runs per innings are actually scored. Don't worry, this isn't an error. The runs per innings figure takes into account extra innings, so this will be more accurate, measuring a team's batting and pitching ability. What I'm going to do now is create 2 new columns to the right here called ATT and DEF, or attack and defense, and what I'll do is come up with a team's attack and defending strength. So the formula for this is going to be a team's runs per innings, D2, divided by the league average runs per innings, D32. Make sure to absolute reference D32. And then you can drag this formula across and down to get the full list of ratings. So I'm going to confirm the average of these ratings is 1 by dragging across the average formula. And once you've done that, lads, I'm going to explain the basis of these ratings. So Texas Rangers have an attacking ratio of 1.29, which means for every 1 run scored by the average team, they score 1.29, meaning their batting is comparatively good for the league. On the other hand, Oakland's rating of 0.77 means they score only 0.77 runs for every 1 run scored by the league average team. Obviously, this rating is really poor. In one more example up here, the Baltimore Orioles have a defensive strength of 0.98, meaning they only concede 0.98 runs for each league average run, and this rating is slightly better than the average defensive rating of 1. Now the next step, lads, is to name some ranges. Over here, I'm going to select the list of teams, and then in this top left-hand box over here, I'm going to type in the name teams, which will name the range teams from now on. Next, lads, name the league average runs in cell B32 here. I'm going to name it average underscore runs. So go up in the top left-hand box, average underscore runs. Next, lads, highlight the list of attacking ratings and name that team underscore ATT. So that's in column F. Again, in this top left-hand box, team underscore ATT, and I'm going to do the exact same thing for column G, or the defense ratings. I'm just going to name that team underscore DEF in this top left hand box again. And once you've done this, lads, merge and center the cells A34 to B35, and in here I'm going to write the text home advantage. Beside this, once you've merged and centered the cells C34 to G35, which is beside our home advantage little box over here, I'm going to enter in a value of 3%. This is just a standard figure I'll use for the video, and it basically just means that a home team will have a 3% advantage overall, so in batting and pitching combined, against the away team. So just put in 3%. Alright, so the next step, lads, is to create another worksheet and then title it results. And here what we'll do is compile each team's expected score within a matchup along with their probability of winning that matchup. So I'm going to merge and center cells A1 to C2 over here, type in home team, and then do the same thing in the cells below, but this time type in away team. Now lads, once you've done that, merge and center cells D1 to J2, and then after some formatting, do the same thing in cells D4 to J5. And in these cells, what we're going to do is create a drop-down list to choose a home and away team to play in a game against each other. So select both cells, go up into the data tab over here, and then you've got to select this little icon called data validation. A little pop-up window will appear, and you're going to select list, and then the source for that list is our equals team, so list of teams. So press OK, and then now we have a drop-down list for both cells. So if we press the top right-hand corner of the cell, we can select the Boston Red Sox, and then the Houston Astros I'm going to select as the away team. Now lads, merge and center cells K1 to L2, and then do the same thing next to the away team. And in these boxes, lads, we're going to find the expected runs of both the Red Sox and the Astros in this matchup. So I'll just add some borders and format this really quickly. And to do this, we can use a simple XLOOKUP function. It's going to be equals XLOOKUP. Our lookup value is the Boston Red Sox in D1. We're looking them up in our named range of teams, and then we want to return their attack rating. So the return array is team underscore ATT. We're going to multiply that by another XLOOKUP function. We're looking up the Astros within teams, comma teams, and then we're looking up the Astros defense rating. So comma team underscore DEF. We're going to multiply that by the average underscore runs. So that was the 4.57 figure earlier on, and then we're going to multiply that by the square root, so SQRT, and our number is going to be 1 plus, go back into the data ATT and DEF worksheet, it's going to be 1 plus 3%. So cell C34 in the data worksheet, close the bracket, press enter, and we can see the Red Sox have a 4.15 expected runs figure. So in this match against the Astros, the Red Sox are expected to score 4.15 runs. Let's do the same formula for the Astros. It's going to be equals XLOOKUP. We're looking up the Astros in D4, comma, we're looking them up in teams, TEAMS, and we're returning the attack rating, so team underscore ATT. Multiply that by the next XLOOKUP function, XLOOKUP open bracket D1, which is the Red Sox, comma, teams, that's our lookup array, and our return array is obviously the Boston Red Sox's defense rating, so team underscore defense. Close bracket, multiplied by the average runs again, multiply this time by open bracket 1 divided by SQRT, so square root, open bracket 1 plus, and then it's the same thing going back into the data worksheet, clicking that 3% C34 cell, close bracket, press enter, and we can see in this matchup the Houston Astros are favored over the Red Sox with an expected run figure of 4.71 to the Red Sox's 4.15. And if we change this team to, say, the Texas Rangers, well, then they become the favorites now. They're the stronger team with an expected runs of 5.03. Before we calculate the probability of either the Rangers or Astros winning in this matchup, lads, we first have to simulate the potential scorelines according to an appropriate probability distribution. And the first step in this process is creating a big banner in row 7, stretching out to column Q, and then after some neat formatting, we're going to type in the text simulated box score. So right in the middle, size 24, simulated box score. And as you could probably guess, lads, under this banner we'll simulate a baseball game based off of the expected scores for each team. In cell B8, you're going to type in a sequence formula, so equals sequence. We want 1 row, 9 columns, start at 1, step 1, and then as you press enter, you'll see a list from 1 through to 9 is spilt horizontally from B8 to J8, and this represents our innings headers. So I'm just going to put equals D4 in cell A9 for the away team as they bat first, and then in cell A10 equals D1 or the home team in Texas Rangers. Now lads, what you can do next is merge and center the cells A12 to A13 and type in the text score. Next to this, you're going to grab the two teams and then be able to pull the score from a simulated game. For example, a 7-1 Astros win. And in cell B12, it's just going to be equals the away team in cell A9 equals A9. And then use the AND symbol to add a colon onto the end of the text. So it's going to be equals A9 and speech mark, colon, speech mark. All you have to do is drag the formula down to apply it to cell B13 and the home team, in this case, the Texas Rangers. And because we don't yet have an appropriate probability distribution to simulate the score lines, in cells C12 to C13, I just want you to add borders to the cells and leave it for later. Next, we're going to create another banner stretching out to column Q in row 15, and the text you're going to type is probability distribution, so big bold letters, size 24. And under this, we're going to distribute a team's expected score using the baseball prospectus formula over to the right here. And of course, lads, the link to this research paper is in the description of the video. Next, merge and center cells A16 to B16 and type in the text variables. Once you've done that, in column A, list the variables M, N, P and B going downwards, which you can again see in the formula on your right. Now, next to these variables, I'm just going to enter the respective values, and these are for M, negative 0.01219. For N, it's negative 1.813. For P, it's going to be negative 0.3865. And for B, it's going to be equals negative 1.042. Once you've done that, lads, it's time to name these variables up in this top left-hand box again. So for M, name it M. For N, name it N. And do the same thing for P and B by just naming it P and B. Next, come up to cell K1, which is the 5.03, and name this cell home underscore score. Do the same thing for K4, but it'll be away underscore score. And they're just naming the home expected runs and the away expected runs respectively. We have one more variable to do, so in cell A21 type in C, and this is the formula for C. You can see it on the right hand side. It's going to be equals home score, so the cell we just named before, that's the 5.03, divided by, open bracket, 9 multiplied by, we're going to multiply it by a sum product formula. So sum product, open bracket, sequence, SEQUENCE, open bracket 20, close bracket, multiplied again by EXP, exponential, and our number is going to be a sequence function. So sequence, open bracket 20, close bracket, multiplied the exponential by M, which is that negative 0.01219, plus, it's going to be another sequence function, sequence, open bracket 20, close bracket, multiplied by P. So we're doing our next named cell plus N multiplied by sequence again. So sequence, open bracket 20, close bracket. And once you've closed the bracket, divide this by the home score, home underscore score. And once you've done that, add B, so plus B, and close the bracket 3 times, press enter, and now that we've calculated C, we can name this cell variable C. So go up in the top left hand box, variable underscore C. Excellent. So your C figure should be round about 0.95, and you'll see this result changes based off of the matchup. So when the Cubs take on the Astros, the C result is slightly different at 0.97. Now, lads, I'm going to create 3 column headers to the right. So the first one in D16 is called score. The second in column E is named home cumulative probability. I'm going to shorten it to this. And then the last one in column F, the last column header that is, will be named away cumulative probability. So add in a little bottom border. And then under the score header, I'm going to use the sequence function to spill a list representing runs scored in an innings of 0 through to 20. So 21 rows, 1 column, starting at 0, stepping in rates of 1. So 0 through to 20. Now, lads, the formula for finding the probability of scoring 0 runs in an innings is to the right, and I'm going to write it out in cell E17 now. That's 1 minus variable C multiplied by sum product, and then open bracket, EXP, so exponential, open bracket, it's going to be M multiplied by home score plus sequence. So that sequence function, we use it quite a lot in these formulas. Open bracket 20, close bracket multiplied by P plus N multiplied by open bracket sequence. So that sequence function again, sequence, open bracket 20, close bracket, divided by home score, close bracket, plus B. And then close the bracket 2 more times. Press enter, and we get a figure of 75.40% to 2 decimal places. Now, what we've got here basically means that in a single innings, the home team, in our case the Cubs, have a 75% chance of scoring 0 runs. And to find the corresponding probability for the away team, all you have to do is copy and paste the formula, but make sure that every instance of home score is changed to away score. So you see how I'm changing the home to away here. Press enter. Yep, so that's K4 instead of K1. Press enter, and our figure's 73%, which is consistent with the fact that the Astros are expected to score more runs, therefore scoring 0 in any given innings is a slightly lesser chance. Now, lads, we have to rewrite the formula to find the probability of scoring 1, 2, 3, all the way up to 20 runs in a single inning. So starting in E18, it's going to be equals variable C multiplied by exponential, open bracket, M times home score plus P multiplied by, and what you're going to do is select cell D18 and only absolute reference the column, not the row, because we want to be able to drag it down, plus N multiplied by, open bracket, again it's going to be D18, only referencing the column, divided by home score, so home underscore score, close bracket, plus B, close bracket, plus, and then the final one is E17 because we want it to be a cumulative probability. Great, so 89.44% means that 89% minus 75% is the probability of scoring 1 run, and the probability of scoring 1 run or less is 89%. So to do it for the away team, just copy and paste the formula. Again, all you have to do is change the home score to away score. So I'm going to do that now. There's only 2 instances of it, so it's really easy. Away score. Press enter, and then drag it all the way down to an instance of 20 runs occurring in 1 inning, so it's pretty unlikely. Now that we've got a probability distribution, lads, we can simulate the outcome of an innings based off of a team's expected runs. So go up to cell B9, and here I'm going to use a simple XLOOKUP function. Equals XLOOKUP, open bracket, rand function, open bracket, close bracket. Now, comma, our lookup array is the away cumulative probability, so that's F17 to F37, make sure to absolute reference that. And the return array is the list of scores, 0 through to 20, and that's D17 hash, which will pick up the whole range as sequence is an array formula, comma, comma, 1, close bracket, press enter, and we have our simulated total for the Astros. And by pressing backspace or refreshing the cells and formulas, those totals will change. Now this formula is going to be exactly the same for Chicago, except we want our lookup array to be the home cumulative probability in column E rather than column F in the away probability. So rand function, then our lookup array is now E17 to E37. Make sure you absolute reference that. And the return array remains D17 hash, which picks up the list below it. 2 commas, and the match mode is 1, close the bracket and press enter. Now that's all done. However, we'll only drag this formula for 8 innings. This is because if the Cubs are leading going into the bottom of the 9th, the game will end early. So that's what I'm going to factor into the formula. I'll put into cell J10 right now, and it'll be an if function. So equals if, open bracket, if the sum of B10 to I10, so B10 to I10, that's the sum of the home team's score in the first 8 innings, close bracket, minus the sum of B9 to J9. So go over to the Astros first innings. The sum of all the away teams' 9 innings is more than 0, comma, return 0. If that's not true, then we want to do another simulation for the Cubs or the home team. So it's going to be XLOOKUP, rand function, comma, we're simulating the home cumulative probability. That's E17 to E37, absolute referencing, and then the return array is D17 hash. So comma, comma, and then of course the match mode is 1, close bracket, press enter, and as we simulate we get different results each time. Now I put a neat right border in here, and we've also got to factor in the possibility of a game ending in a draw after 9 innings. In such a case, the game would go to extra innings, which will simulate to the right of the 9 innings. So lads, in cell K9, you're going to want to type the following formula, equals if, open bracket, sum, open bracket, so if the sum of B9 to J9, that is the away team's score in the first 9 innings, is equal to the sum of, open bracket, and that's going to be B10 to J10. So if the home team is equal to the away team's score after 9 innings, we're going to return another simulation. So XLOOKUP, rand function, our lookup array, well, we're simulating the away team. So the away cumulative probability F17 to F37, absolute referencing, comma, the return array, obviously we're returning a simulated score, so that's D17 hash, comma, comma, our match mode is 1, close bracket, if not, return nothing, so speech mark, and in this case, we have a value of 2, meaning that the away team has scored, let's see, 5 runs, and the home team has also scored 5 runs after 9 innings, so this game has gone to an extra innings. And lads, we can do the same thing for the away team by copy and pasting the formula into cell K10 and then changing J10 to J9. Let's do that now. J10, backspace or remove that into J9, changing J11 to J10, and then of course switching the lookup array from column F to column E, changing the away team to the home team, that is. Now everything else can stay the same, and when you press enter, you can drag this formula across to column Q for both rows in case there is more than 1 extra innings required. Great. So once you've done that, lads, we can do a couple of simulations by refreshing the formulas. What you'll notice here is that after the first extra innings in this simulation specifically, the score was still tied, but clearly in the second innings the Cubs broke the deadlock. It looks a little messy right now, so after a few more simulations, I'm going to enter in a formula within K8 up here that'll spill to label each extra innings played. So lads, the formula for this is equals if, open bracket, if there is a number, is number function, open bracket, in K9, return this text ex dot space, speech mark, end sequence, open bracket, 1 comma count. So for columns, we're counting how many times scores appear in the extra innings simulations. Start at 1, the step is 1, close bracket, comma, speech mark, close bracket. So what this function basically says is if there's a value in the simulations, it's going to pop up as extra innings 1. And don't worry, lads, about dragging this formula across, as it's an array formula because of that sequence function, so it'll spill horizontally for us in extra innings 1, extra innings 2, and so on and so forth. Now that we've done that, we can compile the final score from each simulation in the cells we've designated in C12 to C13, and that's just a quick sum formula, equals sum B9 to Q9 for the away team, close bracket, press enter, and we can see in this simulation the Astros have scored 2 runs. Do the same for the Cubs, but this time it's row 10, so B10 to Q10, close the bracket. And we can see in this simulation the Astros have won 3 runs to 2, which you can manually verify up here. 1 plus 2 is 3, 2 plus 0 is 2, and we can keep doing these single run simulations by pressing backspace in another cell, but I want these simulations to happen 1,000 times in one shot. So I'm going to create a new worksheet and title it Simulations. And then over in cell B1, I want to grab the text of the home team. So that's going to be equals, and then I'm going to go back into results because the home team will obviously change based on who I pick. and it's just going to be equals results D1. So in this case, our home team is the Chicago Cubs, and next to it in cell C1, I want to do the same thing for the away team in cell D4 of the results worksheet. So we've got the Cubs and the Astros here. In cell A2, write the text trials, and under here we're going to spill a list of 1,000 trials or matches for our simulations using the sequence function. So it's equals sequence, and we just want 1,000 rows. So open bracket, 1,000, close the bracket, press enter, and if we go down to the bottom of the range, it has spilled 1,000 numbers for us. Now in B2 will be the single simulated runs scored by the Cubs, which can obviously be found in cell C13 of results. Let's go there. Equals results C13. Press enter, and in this simulation the Cubs or the home team have scored 6 runs, and that is correct as we manually verify it. Do the same thing for the Astros. Make cell C2 equals C12 of the results worksheet, and we've got our simulation here. But what we have to do now for the 1,000 simulations is select cells A2 to C1002. Go up into the data tab over here. Once you've done that, select what if analysis, that's this button over here, and then select data table. Now a pop-up window will appear. Skip the row input cell, and for the column input cell, just select a random cell not being used by the data. Once you've pressed OK, give your computer a second or two to load the simulations, and then once that happens, all the games should appear like this. So if your computer's freezing or something because it's a lot of data the computer's processing, just scroll up and down. And looking into these simulations, in our first game, Chicago loses 2 runs to 8. They continue to lose the next 3 matches until they finally record an 8-5 win in this 5th simulation over here. That's an 8-5 win. We can go back into the results worksheet now, where we'll come up with a formula to grab the number of times the Cubs and Astros win this matchup, and accordingly attain their win probability. So merge and center cells M1 to M2, doing the same thing for the away side. And once you've done that, we can come up with this win probability formula. For the Cubs specifically, their win probability is equal to sum product. We're using the sum product function. Open bracket, and what you're going to do here is put 2 negatives. So it's a double negative minus minus, open bracket. It's going to be B3 to B1002 in the simulations worksheet. So go over here, B3 all the way to B1002. Absolute reference this. Then you're going to put a greater than symbol. So greater than C3 to C1002. What this function basically does is count how many times the simulations in column B, or the simulations of the Cubs runs scored, is greater than the corresponding simulation in column C, or the Astros. So we're counting how many times the Cubs beat the Astros, close bracket, and our result is 445, but of course we want it as a percentage, so divide by the amount of trials, which is 1,000, and we get 0.437, which is equal to 43.7%. Now, as this is still a simulation of only 1,000 trials, refreshing the cells will yield slightly different results each time. So ultimately, the more trials simulated, the more precise the win probability will be. We can use the exact same formula to grab the away team's winning chance, except of course we have to change the B column to the C column and vice versa. So now we're seeing how many times the away team scores more than the home team. Now this sum of 0.438 and 562 should equal 1, otherwise there's something wrong with your formula. And now we have our win probabilities for each team. And the model is done. So good job, lads. Practice switching between teams to see if the win probability updates accordingly. Of course, the team with a higher expected runs should always have a higher win probability. And of course, lads, if you wanted to download this file, click the first link in the description of this video.